Okay, let's begin from the course today. We will just talk about what's the standard deviation, right? Standard deviation, you just use, if it's a simple, we just use this. And I think I would prefer to use the sigma. The data subtrate the mu is the mean, and the subtrate the n subtrate 1 square root of square. Let's do a sigma. And when sigma square is called a variance. Okay, we call it a variance. So let's see about this one. Found the standard deviation for the data from the previous example. Okay, the class 0, 2, 3, 5, 6, 8, 9, 11, 12, 14. What's the example is? Recall that for the ground grouped data, we do not know individual data values, so we cannot describe the typical value for the data with the precision. In other words, we cannot find the exactly mean, median, or mode. We can, however, determine the best estimate of the mean of center by finding the mean of the group data with the formula. So F is the interval frequency, N is the interval midpoints, just as before. So even we have what? Even we have the 0 to 2, the frequency choose the midpoint. Okay, 3 to 5, the midpoint is 4. 6 to 8, 7, 9, 11, 10, 12, 14, 13, 15, 17, 16. So for this one, let's do the midpoint. So it's 1, 4, 7, 10, 13, 14. Okay? So it's 1, it's 24, it's 70, it's 70, it's 0, it's what? 28, right? And add an or. Okay, we'll find my calculator. Okay, so your total frequent is 1 at 6 at 10 at 7. So 7 at 7 is 14, 14 at 2 is 16, 16 at 10 it will be 26, and the sum of the all. Okay, 1 at 24 at 140 at 28, and divided by 26. It's about 7 point, okay. The mean, or we can say the average, is about 7.42, right? And then now we need to find the xi subtrate the mu, okay? So it would be the negative 6.42 and the negative 1.42 and the negative 2. 6 subtrate 7.42, 1.42, yes. And this will be 10 subtrate 7.42, it's 2.58. And the 7 subtrate 7.42, It's my fault. Okay, it's 1 subtract 7.42, negative 6.42, and the 4 subtract, this one is will be negative 3.42, and the negative 0.42, and the 10 subtract 7.42 is 2.58, and this will be 13 subtract 7.42. It should be 5.58. And the 14 subtract 7.42. It should be 6.58. And just square. And add it all. Add the 3.42 square. Add the 0.42 square. Add the 2.58 square. Add the 5.58 square. Add 6.58 square. Okay, you may get will be the 134.18 approximately. I rounded to the hundreds. And the total you have 26, and the unsubtract one is 25, and have the square root. Okay. So about 2.32. Maybe you can just check. Okay, let's see the answer. The standard deviation. Average 7.557. What happened? Okay, and you may see what's the sigma. Sigma is mean the standard deviation, but because its average is different from us. Okay, the sum would be 197, and you must divide it by 26. I think 26. 26. I think the 7 at the 7. Let me check. 9 at the 10 at the 7. 26. Yes, it's 26. So if you add them all, 26 divided by 1 divided by 26, it will be 7.95. Okay. And there is one thing I want to inform you is that since we know it will be sigma xi subtract the mu square, right? And divided by, okay, if it's all the population, xi square subtract 2xi average add, right? Mu square and divided by n if it's a population. Okay, so sigma all the sigma I and the subtract. Okay, what's the xi? It will be the n mu, right? Because what is the average is, it should be the sigma xi divided by n, right? So sigma xi will be the n multiplied by the average. Okay? Is that okay for you? So it will be the 2n mu square at the mu square. Okay, a mu square. So you can see it will be the xi square over n, right? And the subtract the mu square. So that's why it's have the sigma xi square. Okay? But that's only for the population. So let's do extra one. Two students, John and Ellie from different high schools, want to find out who had the highest GPA when compared to school. Which student had the highest GPA when compared to his school? Okay, first, their GPA is different. One is 3 and it's 18. And your school standard deviation, I think that one. 3? Let me check. Okay. So we can do one, we call it standardized, which is mean if you have the different mean and the different standard deviation and the different data, you just do the data, subtract the average, or you can say it's a mean divided by the standard deviation. You can just write down. We call it a standardized. So let's do this one. 2.58 subtract 3 divided by 0.7. What's that? Negative 0.2142. And for this one is 77 subtract 80 divided by 10. It should be negative 0.3. So negative 0.214 is better than negative 0.3. So John is performed better than Ellie. Okay? Because negative is mean below. Please remember this one. We call it for each student, determine how many standard deviation his GPA is away from the average. We call it standardized. You can just use the number of the standard. Okay, that's the program. The value subtract mean divided by the standard deviation. We call it standardized. Standardized. Okay, so we can see the alley perform 0. Negative 0.3 is more below than John. So John better. Okay, so this time it's your turn. Two swimmers, Angie and Beth, from different teams, want to find out who had the fastest time for the 50 meters freestyle when compared to a team. Which swimmer had the fastest time when compared to her team? Let's do this one. Always remember standardize if you have the different mean and the different standard deviation. Okay, I will leave some time to you. Okay, so let's do this one to do standardized. Your time, okay, you can see your time, your mean time is 27.2, and the NG is, okay, its use time less than the mean time, so it's perform better. But we still know the level of how better it is. Don't forget it's a swimming time. So below the mean, which is mean, you perform better, right? It's not like the score. The higher, the better. 1.4. So 26.2 subtract the 27.2 divided by 0.8. It should be negative 1.25. And for 27.3 subtract 30.1 divided by 1.4, it will be negative 2. So if it's a normal distribution, it's a mean. So negative 2 may be here, negative 1.25 may be here. So negative 2 perform better. Best perform better. Are you okay? So PDF 128, please record. See you next time.